Well, everybody, welcome to Fusion 360. My name is Edwin Robledo. I'm part of the Fusion 360 family, and we're really happy that you've decided to join us today. And with me is Jorge Garcia. And not only we work together, he's my friend, and also I think there's a good chance that we'll be lucky enough that Richard Hammerl, our partner from and my friend from Germany, will be joining us as well. So before we begin, let me just do some basic introductions. First of all, I am Ed Robledo. I'm pretty sure if you've used Fusion 360 or maybe you've used Eagle, you've seen some of the videos and some of the blogs that I've been able to create. Started my career in the communications. Jorge Garcia is located here in South Florida, as well as I am. Jorge Garcia has his double E degree as well. Could you tell us just a little bit about yourself, Jorge, if you don't mind?
Yeah, no, I've been using Eagle since before I worked here. It's funny, you gave me support yourself. I called you up once. So, it's interesting how things end up connecting like that.
That
And
is
just enjoyed electronics, enjoy working with Eagle and now Fusion 360 Electronics, trying to bring the best that we can to our users.
excellent. Thank you for that, Jorge. I really appreciate that. And it seems that we have an active chat. So if anything comes up that you think I need to mention, just go ahead and please let me know as we progress. Jorge will be manning the chat as we go along. But, I'd like to make our first announcement is about our insider program. And the insider program is extremely interesting because it actually gives you early access to Fusion 360 latest updates. So if you're going to be using Fusion 360 and you like to work with us, it will give you early access to it, be part of our community, get some inside information. So Jorge is going to be sharing on the chat the link. That way you could go ahead and apply. That way you could most probably become part of the insider program and get some inside information. Our agenda is a little aggressive today, but I'm going to try to work through this as fast as possible. So we want to talk a little bit about what is Fusion 360 and electronic design capabilities. We're going to talk a little bit about some of the benefits of using Fusion 360. If you're an Eagle user, these are some benefits that you don't really have in Eagle that we strongly feel that you could benefit from having these features as well. So we'll talk a little bit about the preserve angles in the schematic, multi-screen support, ODB++ export, which is a capability that was recently added like 2 updates ago, and the manual routing capabilities, especially when it comes to environment settings that we're calling violator options is what we're calling it, and some of the benefits of electromechanical design workspaces. So first of all, I'm not going to really be going in this exact same order because I wanted to be able to have a nice progression flow as we go along as well. So let's go ahead and go live with Fusion 360. Well, first of all, Jorge, can you let me know if you could see my screen right now?
It's fine. I can see it just fine. We're good.
Excellent. Well, what is Fusion 360 Electronics? Fusion 360 Electronic is a collection of editors that allow you to create your circuit board and your schematic and maintain everything neatly synchronized. And yes, the one question that comes up, especially from a lot of Eagle users and some other applications, is they want to be able to work in a multi-screen environment. Just like I'm pretty sure myself and many of you like working on your schematic on one screen and your board on a different screen. And as you could see right here, my schematic screen is actually totally separate from my board screen, as you could see, and they will actually annotate any modifications I do to the schematic will affect the board. And then on the bottom left corner, you'll see I have our library editor. And our library editor is actually rather spectacular. Why? Because our library editor does include a host of IPC compliant templates, as you could see here. And it continues to grow almost with every update. We always add a brand new template. Once you select the template that you're looking for, you select it, enter the mechanical details for the component, and just click on add. Not only will it create the footprint for that component, it actually does create the 3D model as well for that component. Now the footprint as the construction lines that you see there and the 3D model are there for you to admire. So very complex elements to create are actually being able to be created very, very fast. So that's one thing I wanted to see. And as you could see, I am working on multiple screens. But for today's demonstration, I actually want to work with a different tab. So I'm going to actually now put it all together, and that could be easily done. So let's go ahead and put them together all into one environment. As you could see, all the time, I am working in Fusion 360. At no point in time I ever exited the environment, as you could see. So first of all, I like to talk a little bit of the electronic document. The electronic document keeps track of synchronizing your circuit board as well as your schematic and your 3D model as well, as you could see here. So this is actually ties it together. So this allows you to tie different schematics with different circuit boards if you want. So let's say you were working on a watch and you were offering different sizes of that watch. You could use the same schematic and use two different circuit boards, as you could link them in the electronic document. That way you could have different circuit boards pointing to the same schematic editor, to the same schematic environment. Now, the first thing I wanted to show was on the circuit board side. Actually, this is not really the circuit board side. What I really wanted to say is one thing that we like to highlight when it comes to Fusion 360, it's collaboration capabilities. It's hardly, mechanical, electronic engineers, we always work on teams. And the teams could be within the same office or across the globe in different offices. And they will like to see your progression as you work with it. So how is that you do that with Fusion 360? Really simple. If we go to our data panel, the data panel is where where you organize all of your data that is going to be used throughout your project. So let me go ahead and move over to where I'm working with. And this is the data panel for this project that you're looking on. You see the avatars here are opened up, letting me know that I am currently working on the screen. If I wanted Jorge or Richard to be able to access this same data, I would go to the People tab, and I would actually add their email address, their Autodesk account here. An Autodesk account is really easy. It only consists of an email and a password that you need to create. It's totally free. Once I add their name here, they will automatically get an invite. Even if you don't have a Fusion 360, it's not a problem. If you don't have Fusion 360 and your landing page you're going to go to, it's called Fusion Team. So if you click on this little world that I have right here, this will open up a web page that looks something like this. And this is Fusion Team. You do not have to have Fusion to be able to have access to Fusion Team. Okay. So if any management, anybody you're working with wants to see the progression of what you're working on, no problem at all. And please notice that since I'm currently the author working on the project, it actually on Fusion Team, it's letting me know that these files are currently open. So it's 100% synchronized of what's going on the environment. But let's take it to the next level on collaboration. The next level is that I could actually take a look at the schematic. As you could see here, I can make comments, and every comment is going to be versioned. And every participant in this project is going to get alerts that there's brand new comments. I could actually preview the schematic as well, and I could download it from here if I have the rights to be able to download it as well. So as you could see, it makes it very easy to collaborate and work with different teams to be able to do this. And I'm going to show you one more time. So let me go over here, and I like to share the fact that I have go here to the board. And you notice that I've already made some comments on the board right here, as you could see. It's some versions, and I'll go ahead and expand that. And you could do some markups, as you could see here. You could do some markups. You could take a look. You could actually enable and turn off layers as you need to as well. And you could download the board file. as well from this point on. But how about if you're working with a 3D model? Let's say you're sharing this with a mechanical engineer and you want to be able to share the 3D model data. Not a problem, because from here, they'll be able to take a look, put some annotations, some markups, but they are able also to download the board in different formats, from STEP to STL, DXF, and any other format as well. So this just makes collaboration that much easier to work as a team, since not everybody has to be using Fusion, and be able to see the progression of this. Now, based on this, I want to just go ahead and move on. And we'll answer some questions. So I'm going to be going on kind of quickly because we don't want to take this too long. So let's talk a little about on the schematic. And I'll just go ahead and put this off to the side. If we have questions on that, I could return to that later on. Now, let's talk a little bit about on the schematic side. And Jorge mentioned that this would be a good idea. And I thought it was a really good idea as well. Because now when we actually move parts in the schematic, in the past, it would look something, I think it was like this, sort of, as you could see, and I'll zoom in a little bit, the nets kind of like don't preserve their angle, as you could see here, but now we have a mode, which is the default mode, in which the angle is actually preserved, as you could see. Okay, and why is this important? Jorge, can you tell me a little bit? What do you think? Why is this important that we have the preserve angle feature now?
Because it's pretty. Nah, just kidding. Makes things a lot more readable. You know, if like you didn't make that big of a move, but if you have to, you know, move a very dense section of schematic, they're going to end up overlapping each other, and the text ends up becoming hard to read. And then even visually, it's just distracting to see all these weird angles. You know, for the eyes, it's very easy to keep track of it if everything's at 90s. So, you know, that really helps to keep things readable.
And there were times, Jorge, it happened to me that I moved, since we didn't have this feature, and I by mistake made a connection that I didn't even want.
Yep.
Because of the net was in a weird angle, and it actually connected to the connecting point of a pin, and it made an unwanted connection. So this is, besides the fact that it's useful in the sense that it avoids making any type of errors on the design as well. Okay, so another thing we want to talk about is that multi-screen support, which I actually already showed. Remember that you could work on different screens. Now, let's go over to the circuit board. Now, on the circuit board side, we have what we call different environment violator options. And I cannot talk enough about this feature. First of all, Fusion 360, if you've been using it or been using Eagle, it has real-time DRC. In other words, it's constantly checking for any errors that you may have on the design. Okay, it's always checking for those errors that you may have on the design. It's live DRC. But we took it to the next level in the sense that, let me just go ahead and rip up a few lines here for this component here. Let me turn on the nets layer. Okay, now down on the bottom of the screen, you're going to have 3 violator options. You could say ignore violations, push violators, and walk around violations. So let me just start with ignore violations. Ignore violations allows you to do whatever you want on the design. It's a full manual mode to work on the design. So let's say if I go ahead and I select the component and I take this component and I start moving it, go ahead and rip up some more. Let me zoom in a little bit on it again. And if I rip it up, this component, I just rip up the whole line. If I move this component, notice that it's going to allow me to do, I could just go over. But the nice thing is that since Fusion 360 has live DRC, you'll notice that you're getting the hatch lines letting you know that you are creating some violations there. So you will be alerted of it. Now, We also have another violator mode, which is called walk around. So the walk around mode allows you to route a trace without actually creating a violation. So let's say, for example, I start routing this, it's on the top layer. Notice that it does not let me actually force a violation. It lets me go, it will want me to go around any option until I reach my targets in my target area, as you could see here. Now, and the same, I think, the same happens with the components as well. So if I try to move the component, it lets me go over it, but it kind of like it's jumping. So as you could see, this resistor is on the top layer in this trace. You'll notice that it kind of jumps from one side to the other ones because I have the violator mode enabled. So it doesn't let me. And if I try to go to these over here, it's going to jump all the way. So this is a really neat mode. It's kind of semi-automatic, but it lets you have full control of what's going on as well. Now, here's another mode that you could see it in many other applications, but I really feel that Fusion 360 really did a really good job of taking it to the next level. And that's called push and shove. And many of you may say, well, push and shove has been around for a long time. And you're absolutely correct. But in Fusion 360, what we did is that if I'm going to go ahead and start routing this line, and I'm going to start routing this line on the top layer. Oops, I got to enable routing. If I start enabling routing, notice that this is expected behavior from anything that with push and shove, right? We expected this. So as I route, it will actually push lines away. And this is, this is what regular push and shove will do. But we actually made it in a way that if I'm moving a component, look how this works here. I'll zoom in some more. So if I'm actually adding a new part to my design, you don't have to delete all the components. You don't have to delete the connections to accommodate a new part, because with the push and shove violator environment enabled, you notice that it will actually move the traces out of the way. It will not only limit the traces, it will actually even move vias if necessary. If there's space, it will actually move the vias as well, as you could see. And I can't tell you enough what a time-saving feature this is. You no longer have to be ripping up traces. You no longer have to be deleting assets or getting rid of your VS to be able to put your new component down. So this is really what I wanted to show as well when it comes to the violator environment as well. Now, you've created your circuit board, you've laid out your board, and now it's time to create your manufacturing files. And this is another feature that Fusion users are able to enjoy in the app at the moment. Eagle does not have this feature. So if we go over to the manufacturing tab, you're going to notice that we also have now what's called the ODB++ export. And Jorge, if you don't mind sharing with us, why is ODB++ even important?
It's become more and more common for high-end manufacturers to want to have more data, because as we know, Gerbers are literally like the bare minimum to get a board made. They don't carry netlist information in them. They don't carry bill of materials information in them. So what you end up having to do is generate a bunch of different files and send them off to the manufacturer. The idea behind ODB++ is that you just generate this one set of files, and that gives them everything they need. So by doing it this way, if your manufacturer supports ODB++, then they're usually going to be much happier, and there's less conversation, less back and forth that you'll have to have with them. So it's a format that's existed for a long time. Gerber is still de facto, but if your manufacturer supports ODB++, it can make life a little bit easier for you and for them.
If you tell your board house that you do have the ODB++ capability, that's going to be always their preference. Okay. If I remember, and I'm sure of it, they could actually do like different types of simulation, because it's a very smart file and it carries all the data of your design without giving out the IP from the designer. Now, in addition to having the ODB++ there, if we go over to the CAM processor, you're going to notice that Changes. Okay. You're going to notice that it has the different sections here. So it will actually create the ODB++ file as well. It has the preview for the ODB++. It will create the Gerber files as well. If you want to create documentation as images, you could actually enable that. Copy the Gerber configuration. So it will actually create PNG files of each one, your drill, your bill of material, as well as your pick and place. All this data is going to be exported and ready for you to be sent to your board house. You could ask for it to be zipped up, which usually is the way I like to do it. I have it exported, and once you click on process job, it's going to let you know. Now, every section of it, you could set up the type of Gerber output that you wish to use. You could change its configuration, the same for ODB++. So if your manufacturer has certain criteria that they want you to follow, you could actually set up these criteria right here. Okay. And last but not least, on the benefits of actually using Fusion 360, it's an electromechanical design capabilities. And as you could see, we have that board outline there going on, which I've actually inserted into this little camera that I have here, as you could see. And the way I got that board, the way I was able to get this board outline was because I actually captured the camera sketch profile that was created, the sketch profile. So what I did was I click on create and select the create PCB. We have two methods of creating the PCB based on the sketch profile. And that sketch profile was based on the body of this camera, this smart vision camera that we have. And I said it could be associative, in other words, meaning there could be changes on the board and it will adapt, or I could create an independent PCB. And I could just go ahead and start selecting the sketch profiles that I wish to use for my board outline. As you could see, I could just start selecting them here based on the sketch profile that I have. I'm leaving the holes there because I want to use them for reference. That way I know where to place my buttons for my board. So that way I kind of line it up. Once I've selected all of the particular sketch profile, as you could see, I could tell it where is going to be the origin of my file. So I'm going to just use the bottom left corner here. That's going to be the origin. The component side is looking up. The x-axis is looking to the right. Once I've selected my sketch profile, and let's say, for example, I selected this based on projecting different areas of this outline. Once I go ahead and I click OK, and in this case, I don't want to convert the holes to non-plated through holes. I don't want them because I'm only going to use them for reference, for component placement. I'm going to go ahead and click OK. There's my board outline that I need. I'm going to convert this to my PCB outline. So I'm going to push the PCB. So it's not linked to any PCB, and there's my PCB right now. Okay. Then I'm going to go ahead and just select all these holes that came along from the different buttons on the camera. And I'm going to tell it I want this to show up actually on the TDoc layer, on the document layer, TDoc. And now I know exactly where I'm going to be placing all of my buttons, because now I was able to extract that data for this electromechanical workflow. And once I place my components here and I'm satisfied with my components, I could actually push to get a 3D model of my design, and it's going to look something like this at the end. Okay. Well, these are all the primary benefits that I actually wanted to cover today. This is not a really long webinar. I wanted to keep it simple and go straight to the different criteria that really make and bring the benefits. And one thing I wanted to bring up, I wanted to, maybe Richard could help me with this a little bit, if you could enable your microphone, is, Richard, would you mind sharing with us? Because, when Fusion 360 Electronics came out, performance was, was a little challenging, but tell us a little bit of how well the performance is now doing. Now that we, it's been already almost, we're going at 2 years. Tell us a little bit about performance, Richard, if you don't mind.
Well, Edwin, yeah, great question. So it's really, I'm happy to share that we have some improvements in the recent update about performance, especially when you push from 2D to 3D, that's something, this takes some time until the 3D board is rendered and visible. In recent update, we had some improvements, especially for boards with a big number of holes and big number of components. We improved in an average of about 25%. That's the time you save now if you push it. For some boards, you really have big improvement. It always depends on what's on the board, but the best value was one board which where you save about 75% of your time in pushing it to 3D. So we had really great progress. You know, it's small steps here and there, but it's an ongoing process. The dev team is always working and looking for improvement performance-wise. So that's really great. And we, as far as I know, we will see some improvement for further updates, not too far away from now.
Excellent. Thank you, Richard. I really appreciate that. Yeah, performance-wise, you know, I just echo what Richard said. It's really amazing. And as he stated, some of the boards have improved almost 90%. And right now, as Richard was saying, I did a push for the hardest one, which is to include the solder mask. While Richard was letting us know, it actually generated the 3D model, and you'll notice the depth of the solder mask is right there. So it's improved vastly when it comes to actually creating the 3D model of the design. That way you have a pure electromechanical design experience. So you could actually lay out the board from the 3D model from this point on. Here, if you want to, I prefer working on the 2D PCB, but you have the capability of moving assets directly here on the 3D model or as well as in the assembly. Well, this is everything we wanted to cover today.